All right, let's talk about tornadoes. So, what is a tornado? Tornadoes form from a low pressure thunderstorm. And the low pressure is important because that's what allows the air to rise upward in a tornado. So, the funnel of a tornado is air trying to rise up into the low pressure storm. Now, tornadoes usually form over land. If they form over water, we call them water spouts. In the US, which is number one for tornadoes in the world, we get an average of about 800 tornadoes reported every single year. There might even be some extra that just go unreported. Now, what is the actual definition of a tornado? A tornado is defined a violently rotating column of air extending from a thunderstorm to the ground. Now, there could be a thunderstorm that has a violently rotating column of air that just doesn't make it to the ground. Still not a tornado. So it has to make it to the ground, it has to touch for it to be a tornado. Now, usually tornadoes will either have dirt or debris, maybe even water vapor that signifies that they are there. But until they touch the ground, sometimes they're pretty hard to see. So this one has touched the ground, so that's why it's a little bit easier to see there. Now, where do they come from? You may have already figured that out. Tornadoes come from thunderstorms, but not just any thunderstorm. Well, at least the strongest tornadoes can only come from something called a superstorm. Now, I have a radar picture one of right here. And even though the strongest rain is back here in red, the actual thunderstorm tornado is actually from way over here in front. So the rain almost follows behind the tornado. Go figure. Now, what makes tornadoes so dangerous is that even though they're kind of small compared to the actual thunderstorm, you can see very small tornado area versus the very large thunderstorm, is that they have a really fast wind speed. So even though hurricanes could be something like hundreds of miles across, a tornado, if it comes over you, it's going to have a lot faster wind speed than a hurricane. Now, let's take a closer look at a supercell thunderstorm. So what's the difference between a supercell and a regular thunderstorm? Mainly this rotating column of rising air. Now, all thunderstorms have rising warm air. That's how they're powered. But with a supercell thunderstorm, some of that rising air not only rises upwards, but is also spinning in a spinning column as it rises up. And that allows, well, some of that column to reach down all the way to the ground as a tornado. So it doesn't happen for every superstorm, or every supercell thunderstorm does not always have a tornado, but most large tornadoes come from supercell thunderstorms. You can get smaller tornadoes like EF1s from a regular thunderstorm or a squall line or something like that, but these ones are the ones that do the most damage. Now, how much damage can they do? Speaking of damage, well, a lot. For a single tornado, up to about $3.2 billion per tornado, which is quite a bit. But that's only for like the biggest tornadoes, the ones that actually hit a city or something like that. So you could have a tornado that happens in an empty field and it could barely do any damage at all. So it just depends on the tornado, and it also depends on where it hits and how prepared are the buildings for a tornado when they do get hit. So there's a lot dependent on the tornado, not just its strength. Can you actually survive getting hit by a tornado? Like, let's say you're caught out of shelter, you're just in your house, which doesn't have a tornado shelter. Well, the answer is yes, but I wouldn't recommend risking it. So don't try it. Definitely take shelter under something strong. They recommend an inside bathroom away from windows for obvious reasons. The windows would shatter and send flying glass everywhere. So even if you don't have a tornado shelter in your house, it is still definitely possible to survive a tornado, even as much as an EF5 tornado. But I would not recommend it, especially if it's coming in your direct path. Now, where do tornadoes occur? Well, like I mentioned earlier, United States is number one for tornadoes, and we have this area called Tornado Alley. So on this picture right here, in areas in dark green and even darker green, that would be generally considered Tornado Alley. But anywhere in green gets an average of about 1 to 3 tornadoes every year. So anything that's green on this map, and you can see it's most of everything east of the Rocky Mountains has some tornadoes. Now, you can get some water spouts near the coast of California and some in Arizona, but for the most part, these are going to be weaker than any tornadoes over here. And yeah, this is definitely Tornado Alley right here in the middle of the country. But it's certainly possible to get tornadoes here, but they tend to actually be weaker than tornadoes that happen right over here in Tornado Alley. Florida can get some pretty strong tornadoes too. Now, when do they occur? April to June. And there's a reason for that too. That's the only time there's enough warm, moist air rising up from the Gulf of Mexico or off the Atlantic onto land. And also you can get some cold fronts coming from north, maybe Canada or northern United States. And when those cold fronts and that warm air meets, you can sometimes get some very powerful thunderstorms. Now, usually happening along cold fronts, like I mentioned, they don't have to have a cold front. It could just be an unusually strong low pressure system. How about how long do they last? Well, here's the thing. Most tornadoes don't really last that long. The problem is, the stronger they are, usually the longer they last. So a few second tornado that touches down and then stops is generally going to be a weaker one. A 5-minute tornado is probably going to be an EF1, somewhere around there. Is when you really start getting into EF4s and 5s. That's when we're talking they can last up to hours. Now, in the past, it was thought there could be tornadoes that could last up to a day, but that's pushing it. So several hours, we're going to call that the limit because we don't actually think it's multiple tornadoes for the previous reportings of tornadoes lasting for a day. So the bigger they are, the longer they last, unfortunately. Now, how fast do they move? Could you outdrive one in your car? Yeah, you could, but like I said, you probably shouldn't try. They can go up to 60 miles per hour, which most cars can outrun that, but what if there's something in the road that blocks you? What if you get stopped? What if you hit something? What if the road turns towards the tornado? So I wouldn't recommend it. On average, they don't even move 60 miles an hour, 10 to 20 miles per hour. So you're definitely not outrunning them on foot, but you could definitely outdrive them. So let's move on. I think we already mentioned the Supercell thunderstorm. Just a few extra vocabulary words for you here. So descending from the thunderstorm, there's something called a wall cloud. It has a very distinctive shape, and it's almost like a pre-warning that you might get a tornado. Now, you don't have to have a tornado just because you have a wall cloud, but you do need a wall cloud to make a tornado when it comes to a supercell. So tornadoes, they do come with a slight early warning system, and obviously we can detect that the supercell thunderstorm is headed your way. So usually people will get some warning that these things are coming. Now, how big is the tornado part? Well, even though it's tiny compared to the supercell thunderstorm, the max width for a tornado, 2.6 miles wide. Obviously, that's only for the biggest one. They're usually much, much smaller than that. And how bad are they? Well, they're pretty bad. Not as damaging as a hurricane, but they can still cause a lot of fatalities and a lot of injuries every year, and a lot of damage. I think in the last 40 years, severe storms have caused something like $250 billion in damage over the last 40 years in the U.S. So very damaging things. Not as much as hurricanes, but still quite damaging. They also include the fastest wind ever recorded. Right there, you can see 318 miles per hour. Whereas, the strongest hurricanes are 155, 160, 170. These are almost twice as fast as the strongest hurricanes. Now, I mentioned earlier that the strongest single tornadoes so far happen in Joplin, Missouri, with a $3.2 billion price tag. So tornadoes can cause, at least single strong tornadoes can cause a lot of damage. They don't always have to if it's a weaker one, but the fast winds aren't what causes damage. It's not like the wind blew and knocked your house over, or the wind blew and knocked a car over. It's the fact that tornadoes pick up other stuff and throw that stuff at people. That's the most dangerous part. That's what causes the most damage. So if we look at some debris, we can see in this picture of Joplin, Missouri, there's debris thrown everywhere. And this is after the tornado. You can still see there's debris left on the ground after the tornado hit. And if we look, I'll outline it in a line for you right there. Areas that weren't hit by the tornado, they're not damaged. So you really only get damage directly where tornadoes hitting directly where it's throwing those objects around. Farther away, you get smaller objects. They don't cause as much damage. I'm sure there's still a little bit debris thrown around here, but they've cleaned it up by the time this picture was taken. So tornadoes very, very damaging if they hit you. If you're outside of where the tornado is, the damage drops off severely. The winds drop off and the debris flying away drops off pretty quickly. Now let's take a look at another piece of debris flying around. So we've got a piece of plywood that's driven through a palm tree. It takes a lot of power to do that. That's not easy to do, and you can see the power of a tornado and its wind is throwing things. How about another one? How about some planks of wood that have just punctured through a roof? So you can see even the shingles on this roof are still standing, the playset is still standing, the fence is still standing, but the fact that these planks of wood were flung so quickly, they were able to puncture through the roof and cause damage. So while the winds may have not been enough on their own, throwing things around is what caused the damage for this tornado. And how about a fork in concrete? That's not easy to do. Or how about a vinyl record in a pole, a piece of wood? I guess it's a phone pole or a power pole, doesn't really matter. But if you know about vinyl records, they're not exactly the sturdiest objects out there. So very interesting that it would be able to do that, and it's because it was moving so quickly in the wind. Now let's talk about the Enhanced Fujita scale. Fujita scale. It rates tornadoes based on how much wind they do, but also how much damage is produced. And that's the difference from the previous scale. The previous scale only measured based on wind speed. So damage produced is also included in there. Let's start with the weakest ones and move our way up in the enhanced scale. So light damage, EF0, your smaller tornadoes, maybe you can cause some roof damage, maybe some leaves will be stripped. Not that much damage for anything that's secured and tied down. It's not going to move around. Even non-tornado winds can reach up to the speed. You move up to EF1, and you can see with EF1, there can definitely be some damage. Roofs can be stripped, shingles can be moved around. You can see debris laying around, so planks of wood, very damaging. As soon as one house breaks up, it releases its wood to damage other places, garage doors. Let's move up to EF2. So mobile homes destroyed, permanent homes can be shifted, walls can start falling down, metal poles can be bent, trees can start losing their bark. With EF3, you can see this entire tree, all the leaves are gone. Looks like it was a pine tree. There's no needles there anymore. Even some of the bark is stripped off the tree. Also, there's some police tape. But if we look at EF3, even strong structures, what you would think of as strong, can also be destroyed. And then why they recommend hiding in the inside of your house? Well, the first part of your house that's going to be destroyed is the outside. So in an EF3, hopefully you're never in one, but there's a reason you should hide in the middle, because that can even destroy an entire house. We move up to EF4, and it's pretty bad if an EF4 hits. So even concrete buildings like schools, roads, even the asphalt on roads itself can be ripped up and destroyed. You can see the tree, it didn't just lose its leaves. There is no tree left there anymore. It's just a trunk. The branches, most of them are gone. And even on the branches that survived, some debris has hit it. And you see, look at all this debris. All of that is just fuel in the tornado to hit something else. Even the roof of this car is gone in that image. And then we get up to EF5, which basically within EF5, there's just nothing left. The concrete part of your foundation of your house is the only thing that remains in EF5. Even that concrete, you can see these are cinder blocks in this image. The cinder blocks have just been pulverized by debris. Now, sure, if you had concrete sitting there in a wall, you just hit it with 200 miles per hour wind, it probably wouldn't do anything. But it's all that stuff that's getting flung around at 200 miles per hour that can cause the real damage. So with an EF5, think of it as the ground is scoured and just everything is ripped off the ground. So definitely do not want to be in one of those. And that was the one we talked about earlier with Joplin. This one right here is Parkersburg 2008. They were both EF5s. And here's another one. This one's from 2007, Greensburg. It was another EF5, 1.7 miles in width. And you can see there's not much left. There are some tree trunks. They've already started cleaning up in the debris. It looks like a few buildings survived. Just like with the weaker tornadoes, if you are not inside the funnel itself, the damage drops off pretty significantly the farther you are away. But unfortunately for this one, this 1.7 mile wide tornado, which is huge, can hit a large portion. Basically traveled right through the city, and it traveled for a long distance, 22 miles. So definitely not something you want to find yourself in. Here's another video, or sorry, another photo from the aftermath as well. So almost complete destruction. Very few structures still standing. One there, but that's pretty much it. And so here's some before and after pictures, just using Google satellite view, and you can see before trees, and then these are right next to each other. So this one is actually not the same image twice, but you can see the before and after side by side, and there's not much left in the after. The roads, some places that didn't get hit by the tornado down here, even the school building right there, pretty much ripped apart. This one is the same place twice, so there's the same intersection as right there, and you can see the tornado looks like it came about north-south right there, and stripped away most of everything. All the green is gone, the grass, no grass left even, it seems, and definitely no houses. So very unfortunate, but EF5 tornadoes can happen. Now let's talk about a little bit lighter. How about something that isn't tornadoes? So FireWhirls and dust devils. So not technically a tornado, one, because they really don't spin fast enough, and two, they're not really powered by a thunderstorm. So with a FireWhirl, it's powered by the heat of the fire. Remember, tornadoes form from low pressure air rising up. With fire, fire provides the air rising because it's got the heat. A dust devil powered by the hot air nearby from the sun hitting the ground, and so that dust devil can cause the air to rise as well. So both of these can have significant winds associated with them, but not technically tornadoes, and I doubt they would even reach EF0 style winds.